Okay, so in this video, we will look at the confidence interval for P, the population proportion. Trying to recognize one of these problems, of course, it'll say confidence interval or interval estimate. You'll be given some confidence level like 90 or 95%, and it will say the population proportion. Okay, so some of the things we have here, this is a categorical variable. It's binomial. Either you voted for a candidate or you didn't, or the item was good or it wasn't. You made a purchase or you didn't. It's a simple random sample, and the number of yeses and the number of nos must both be greater than or equal to 15. You'll sometimes see that yes written as n times p, or n times p hat, and n times q hat. So if you had 100 people in your sample and the sample proportion was 0.4, then 0.4 times 100 is 40. That would be the number of yeses. So the number of yeses is equal to np hat, and the number of no's then would be n times q hat. I prefer the yes and no, but you'll see plenty of text and things that will state it this way. Again, we're using 15 in this course. That's what our text uses. But you certainly will see other texts that say greater than or equal to 5 for both of them, and some that'll say greater than or equal to 10. Okay, so it's the statistic plus or minus a confidence coefficient times the standard error. So the statistic is p hat, z is the confidence coefficient, and the standard error is the square root of p hat q hat over n. If you don't have it yet and you're in my class, please make sure you've printed off the formula sheet so that you'll have these handy. And you can use those on the exam, or it would be fair use to use them during the exam. Okay, so we'll take an example here, and we have a simple random sample of 1,200 registered voters, 630 of whom favor candidate A. We're assuming there's just two candidates in this, and we want to construct a 95% confidence interval, and it should say here for the population proportion. It's binomial because they only have two options. Either they're going to vote for the candidate or they're not. Okay, so that's your problem. And, the number of yeses are 630, and the number of nos would be 1,200 minus 630, or 570. Both of those are greater than 15, so we're good on the sample size. So just pulling some information out of the problem. N is 1,200. There were 630 yeses. So the sample proportion will be 630 out of 1,200, or 0.525. And then we want a 95% confidence interval. So once you've pulled the information out of the problem and computed that sample proportion, we pretty much just have a plug and chug kind of thing here. So at the top we have the information we pulled out of the problem. Then we have the confidence interval formula. Statistic plus or minus confidence coefficient times standard error. P hat plus or minus z times the square root of p hat q hat over n. So p hat is 0.525. The z for a 95% confidence interval will be 1.96. Then we'll have the square root of p hat, which is 0.525, q hat, which is 1 minus the 0.525, or 0.475, divided by n. And that all computes out to be 0.497 to 0.553. And since that interval includes 0.5 and numbers below that, this would be referred to as a statistical dead heat, that either candidate could win. That candidate A, we expect to get somewhere from slightly below 0.5 to up, or 0.497 up to 0.553, or 55.3% of the vote. But in either rate, it does include 0.5, so n numbers less than that, so there is the potential for that this candidate might not win the race. We're within the margin of error. Okay, and that's what I have for our first video on the confidence interval for a population, for a single population proportion.